All right, so get this. Imagine teaching AI like you'd teach a friend, showing them examples and letting them learn by doing. That's basically what in-context learning is, or ICL for short. But there's a catch. Traditional ICL kind of gets overwhelmed easily. It needs a ton of examples and just way too much computer power.
Right.
And so that's where today's deep dive comes in. We're tackling a paper straight out of the University of Edinburgh. It's all about a fascinating new method called mixtures of in-context learners, or MOICL for short.
It's pretty amazing. Think about it. If you were trying to learn something new, would you rather have like one giant textbook on everything?
Oh, gosh.
Or several smaller guides, each one focused on a specific part?
I would definitely go for the focus guides for sure. Less overwhelming.
Exactly. And that's MOICL's secret weapon. Instead of one AI trying to learn from this massive data set, it breaks the task down and creates specialized experts.
Okay.
Each one trained on smaller chunks of information.
So like a team of mini AIs all working together. I'm already intrigued. But how does MOICL decide which of these experts to trust?
That's where it gets really clever.
Yeah.
MOICL actually acts like a judge. It evaluates each expert based on their past performance. So think of it like figuring out which of your friends gives the best movie recommendations. You learn who to trust over time.
Okay, that analogy makes sense. But this paper claims that MOICL goes beyond just handling like different types of data. It actually solves some pretty major AI problems.
Oh, yeah. You're catching on quickly. One of the biggest headaches in AI development is something called a label imbalance.
Oh, I've heard of that.
Yeah. So imagine training an AI on movie reviews, but most of the reviews are positive with only a handful of negative ones.
Okay.
The AI might become really good at recognizing positive reviews, but struggle with the negative ones, simply because it hasn't seen enough examples.
That sounds like a recipe for bias. How does MOICL fix that?
MOICL can actually even the playing field.
Wow.
It helps the AI learn effectively even when the data is skewed, ensuring that it's fair and accurate regardless of those imbalances in the training data.
That's amazing. That's a big problem in a lot of AI applications.
There's a huge problem.
Yeah, so MOICL makes AI more fair. But what about all that messy real-world data? Can it handle that too?
Absolutely.
Yeah.
Think about it. In a perfect world, all our data would be perfectly organized and labeled. But reality is messy. Sometimes the information is irrelevant, or even just plain wrong.
Yeah.
Traditional ICL can get thrown off by this. But MOICL is built to be a noise buster.
Wait, so it can identify and filter out the bad information?
Yes.
That's impressive. How does it even know what's right or wrong in the first place?
Well, the researchers put MOICL to the ultimate test. They intentionally scrambled some of the answers in the training data.
Oh, wow.
And the result? MOICL still performed incredibly well because it could figure out which examples were trustworthy and which were basically nonsense.
Wow, that's like having a built-in BS detector for AI.
Right.
This is already sounding way more powerful than traditional ICL. Is there anything else that MOICL can do?
Well, we've only just scratched the surface. Remember how we talked about traditional ICL being a resource hog, needing tons of computing power?
Yeah, that was a major drawback for sure.
Well, MOICL tackles that head on. It's significantly more computationally efficient because it breaks the problem down into those smaller chunks for each expert.
Okay.
And this means faster AI training and development, and ultimately AI applications that are quicker and more responsive for you, the end user.
So it's not just smarter, it's faster too.
Yeah.
This is starting to sound like the ultimate AI upgrade, but earlier you mentioned something about an anti-expert twist. Now that's what I'm really curious about.
Yes. This is where things get really interesting.
Okay.
The researchers found that sometimes certain example subsets actually perform worse than random. It's like having a friend who consistently gives terrible advice.
Right.
Almost like an anti-expert.
Hold on, I'm confused. How can learning from something that performs worse than random actually be helpful? Wouldn't that just lead the AI astray?
It seems counterintuitive. But think of it like this. Sometimes knowing what not to do is just as valuable as knowing what to do. By understanding the patterns of these anti-experts, MOICL can actually refine its decision-making and avoid those same mistakes.
Okay, that makes sense. It's like learning from both your successes and your failures, or in this case, the failures of others.
You got it. And this ability to learn from both experts and anti-experts is a big part of what makes MOICL so robust, and adaptable.
Okay, my mind is officially blown. But before we go any further, I think we need to unpack how MOICL actually works on like a technical level.
Sure.
You mentioned these specialized experts, but how do they actually learn and communicate with each other?
Well, it all starts with how MOICL divides and conquers the learning process. Remember those specialized experts we talked about?
Yeah.
Each one receives a specific subset of the training examples, almost like assigning different chapters of a textbook to different students.
Right. So each expert focuses on a specific aspect of the task. But how do they work together to form a complete understanding?
That's where the real magic happens. MOICL doesn't just blindly trust each expert's opinion. It actually learns how much to trust each one based on their past performance. Just like you might trust one friend for movie recommendations, but rely on another for restaurant suggestions. MOICL figures out which expert is most reliable for different types of input.
Okay, so it's constantly evaluating the credibility of its own experts. But how does it actually combine all this information to make a final decision?
Well, that's where things get a bit more technical.
Okay.
It uses a mathematical formula to combine the predictions of each expert, taking into account their assigned weights. Think of it like a weighted average, where the most trustworthy experts have a bigger influence on the final outcome.
So it's not just a simple majority vote.
Yep, much more nuanced than that.
Okay.
And this is what allows MOICL to be so effective. It considers the strengths and weaknesses of each expert, ensuring a balanced and well-informed decision. Even those anti-experts we talked about play a role.
Right. Those friends who give terrible advice, somehow even they contribute to the learning process.
Exactly. It's all about learning from both positive and negative examples. This ability is crucial for making MOICL robust and adaptable. Think of it like a built-in error correction system.
This all sounds incredibly complex. I have to ask, how did the researchers even come up with this idea?
They were motivated by the limitations of traditional in-context learning. They knew there had to be a more efficient and adaptable way, especially as AI models continue to grow in size and complexity.
So MOICL is a response to the challenges of scaling up AI. It's a way to ensure these massive models can still learn effectively without needing a supercomputer to run them.
That's a great way to put it. And it's important to remember this is still early-stage research. There's a lot more to explore and refine, but the initial results are incredibly promising.
Well, I, for one, am hooked. Before we wrap up part 1, can you give us a sneak peek at what's coming up next?
Absolutely. In part 2, we'll delve deeper into the technical side of MOICL, exploring the tools and techniques the researchers use to develop and test this groundbreaking approach.
Sounds fascinating. Can't wait to learn more. See you all in part 2.
Welcome back. Last time we left off talking about how MOICL tackles some of the biggest challenges in AI, from biased data to computational inefficiency.
Right.
Now let's dive into the technical engine room and see how it actually works.
I'm all ears. This mixture of experts idea is fascinating. But I have to admit the technical side is still a bit of a mystery to me.
It's definitely more complex than traditional ICL.
Yeah.
But that's what makes it so powerful.
Yeah.
One of the key ingredients is something called a hypernetwork.
Okay.
You can think of it like a master conductor, leading an orchestra of experts.
Okay. I'm intrigued. But how does a hypernetwork actually work? Is it like some kind of super AI controlling all those smaller experts?
Not quite. It's more like a specialized neural network that learns to generate the weights for each expert.
Okay.
Remember how we talked about MOICL figuring out how much to trust each expert?
Uh-huh.
Well, the hypernetwork is the one making those judgment calls, dynamically adjusting the weights based on the specific task at hand.
So it's constantly evaluating the performance of each expert and tweaking their influence on the final decision. That's pretty impressive.
It is. And here's the really cool part. The hypernetwork isn't just a static controller.
Right.
It's actually learning and adapting alongside those experts.
Wow.
It's a constant feedback loop where the hypernetwork learns which experts are performing well
Okay.
and adjusts their weights accordingly, leading to even better overall performance.
It's like a team of AIs all working together, each contributing their unique strengths and constantly improving as a group. That's a far cry from the traditional one-size-fits-all AI models.
Exactly. This collaborative approach is one of the things that makes MOICL so exciting.
Right.
It's not just about building bigger and more complex AI models. It's about building smarter, more adaptable systems that can learn and evolve over time.
Okay, I'm starting to see the potential here, but I'm curious about the research itself. How did they actually test this MOICL approach? What kind of tasks did they throw at it?
They ran a whole battery of tests, focusing on text-based tasks, like classifying movie reviews or analyzing sentiment in social media posts.
Okay.
They wanted to see how MOICL performed compared to traditional ICL. especially when dealing with challenges like biased data or noisy examples.
And how did it stack up?
The results were remarkable. Across the board, MOICL consistently outperformed traditional ICL,
Wow.
especially when dealing with those tricky situations we talked about earlier. It was more accurate, more efficient, and more robust to variations in the data.
So this isn't just a theoretical concept. It actually works in practice. That's pretty exciting. But if MOICL is so much better than traditional ICL, why isn't everyone using it already?
Well, remember, this is cutting-edge research, hot off the presses. It takes time for new ideas to filter through the AI community and be implemented in real-world applications. Plus, there's still a lot of work to be done to refine and optimize MOICL.
So it's like any new technology. There's a period of development and adoption before it becomes mainstream. But it sounds like MOICL has the potential to be a real game changer in the AI world.
Absolutely. It challenges our assumptions about how we build and train AI models. It's not just about brute force computing power anymore. It's about creating systems that are intelligent, adaptable, and able to learn from a variety of sources, even those that might seem unreliable at first glance.
This idea of learning from anti-experts is still boggling my mind. It's like saying we can learn valuable lessons from people who consistently make bad decisions. How is that even possible?
It's all about pattern recognition. Think of it like this.
Yeah.
Imagine you're trying to learn how to play chess. You could study games played by grandmasters and try to imitate their moves.
Right.
But you could also learn a lot by studying games where players make critical blunders, understanding why those moves led to defeat.
Okay, I'm starting to see the analogy. By recognizing patterns of failure, we can avoid repeating those same mistakes ourselves.
Exactly. And that's what MOICL does so brilliantly. It doesn't just dismiss those anti-experts.
Right.
It actually analyzes their behavior, extracts valuable insights, and uses that information to improve its own decision-making process.
It's like having a built-in safety net that prevents the AI from falling into the same traps that others have encountered before. That's a pretty powerful tool to have in your arsenal.
It is, and it's one of the things that makes MOICL so robust and adaptable. It's not just learning from the best examples.
Right.
It's learning from everything, even the mistakes and failures, which ultimately makes it a much more well-rounded and intelligent system.
This whole conversation has been a real eye-opener. I'm starting to see AI in a whole new light. It's not just about building machines that can mimic human intelligence. It's about creating systems that can learn and evolve in ways that we never thought possible before.
You're getting it. And MOICL is just one example of the incredible innovations happening in the world of AI. As we continue to push the boundaries of what's possible, we're bound to discover even more amazing and potentially transformative technologies.
I can't wait to see what the future holds. But before we get too carried away with the possibilities, let's bring it back down to earth for a moment. What are the practical implications of this research? How will MOICL actually impact the way we use and interact with AI in the real world?
That's the million-dollar question. And it's one that researchers are actively exploring. One of the most exciting aspects of MOICL is its potential to democratize AI, making it more accessible and affordable for a wider range of users.
Okay, I'm listening. How does MOICL make AI more democratic?
Remember how we talked about MOICL being more computationally efficient than traditional ICL? Well, that translates into lower costs and faster development times. Which means that even smaller companies or individuals with limited resources could potentially develop sophisticated AI applications.
So it's not just about making AI more powerful, it's about making it more accessible to a wider range of people and organizations. That's a huge step forward.
It is, and it opens up a world of possibilities. Imagine startups, researchers, or even just hobbyists with innovative ideas being able to build and deploy AI solutions without needing access to massive supercomputers or huge data sets.
That's a future I can get behind. But what about the potential risks? We've all heard those cautionary tales about AI becoming too powerful and potentially even dangerous. Does MOICL address those concerns?
That's a crucial question. And it's one that we can't ignore. As with any powerful technology, there are potential risks and challenges associated with AI. And MOICL is no exception.
So what are some of the potential downsides we need to be aware of?
One concern is the potential for bias. Even though MOICL is designed to address data bias, there's always a risk that the AI could still learn and perpetuate existing societal biases present in the training data.
That's a valid point. Just because the AI is more sophisticated doesn't mean it's immune to the flaws and biases that exist in the real world. How do we guard against that?
It's all about careful data selection and ongoing monitoring. We need to ensure that the training data is diverse, representative, and free from harmful biases. And we need to continuously evaluate the AI's performance, looking for any signs of bias or unintended consequences.
So it's not just about building the AI, it's about building it responsibly and ethically.
Yes.
With safeguards